What are the frontiers of observational astronomy? Let's look at it in terms of cosmology, the history of the universe. How far have we got in our approach to the Big Bang, which happened 13.7 billion years ago? The first frontier of observational cosmology comes from optical observing. There was a time before which there were galaxies and stars, and astronomers have been looking hard for a couple of decades towards that time, first light. We think it happened in the first couple of 100 million years after the Big Bang. Optical telescopes like the Hubble Space Telescope and even larger ground-based telescopes have almost got us to that point, seeing out through 40 billion light years of space and back through over 13 billion years of look-back time. The time of first light is uncertain. It's also uncertain whether stars or galaxies formed first. But the best guess is that massive stars formed first and gradually aggregated into small galaxies, which then aggregated into larger galaxies like the Milky Way. One idea of pushing back to the very first light in the universe, which is to say the first population of stars that ever existed, is to use gamma-ray bursts. These are intense flashes of radiation which happen when a massive star explosively detonates with energy far greater than even a supernova. It's a rare cataclysmic event that only happens for the most massive stars, perhaps 20, 30, or 40 times the mass of the Sun. These gamma-ray bursts release a torrent of radiation which for a few seconds outshines the entire rest of the universe in gamma rays. And we have sensitive gamma-ray telescopes to detect these. Scientists think that we might be able to use gamma-ray bursters to see before first light, or to the very dawn of time when the first stars formed, perhaps 100 million or only 50 million years after the Big Bang. The earliest landmark, looking back in time, where we have detailed information of the universe, is the cosmic microwave background radiation. This is when the universe became transparent, after having been a hot, dense, and opaque gas for the previous time. The microwaves we see with radio telescopes come from a time about 300 or 400,000 years after the Big Bang, very early on. If you're in the universe now as a middle-aged person, this is a baby picture when the universe was just a few hours old. Current generation of radio telescopes, some of which are in space, are able to put exquisite detail on these microwave maps. And these are telling us about the parameters of the Big Bang model, such as the curvature of space early on, the amount of dark matter and dark energy in the universe compared to normal matter, and even more exotic ideas such as ruptures in space-time and cosmic strings. This is the current and conventional frontier of observational cosmology. Beyond this, there is a time, supposedly, in the infant universe when it expanded dramatically in an episode called inflation. Inflation is thought to have been caused by the separation of three of the forces of nature that are now quite distinct in their properties. This drove an exponential expansion of the universe when it was essentially zero age. The actual number is 10 to the minus 35 seconds. An incredibly small iota of time after the Big Bang. It seems impossible that we could observe such an event or have information from that time. And yet there are ideas of how to use microwaves to detect the inflation event. The inflation event is part of the standard Big Bang model because it's used to explain why the universe now is flat and homogeneous or uniform. The final frontier in theoretical cosmology involves highly speculative theories that seek to explain why the Big Bang happened at all and whether there was a precursor state. These are exotic theories involving superstrings and multi-dimensions of space-time. Once again, it seems implausible that we could possibly test such an idea. For example, were there other universes out there, or is ours the only one? And yet there are missions being designed, or concepts being investigated, whereby in 10, 20, maybe 30 years, space and ground-based missions may be able to diagnose questions like this and ask if we live in the only universe there is, or whether there are hidden dimensions of space-time. Astronomy never stands still. The observational techniques we use today will still undoubtedly be used in a few decades, but we're reaching for new ways to understand the universe. To summarize, conventional observation takes us some way back in the history of the universe, to first light, the origin of the first stars and galaxies. But by clever use of microwave techniques and space missions yet to be approved, astronomers hope to go back to within an iota of time from the Big Bang itself and ask profound questions such as whether our universe is the only universe or the three dimensions of space and one of time that we observe are not all that there is.